Unit 7. End of Life. Lesson 1. Materials. This lesson aims to introduce principles of circular economy, in particular related to end-of-life options for materials and products. The lesson wants to be a resource for professionals and students related to the wood furniture industry and show ways to organize and manage their production and supply chain considering the end of life from a circular economy point of view. The learning objectives are: differences between end-of-life or waste materials, byproducts and end-of-waste. How to privilege easily separable technical plus biological nutrients. How to privilege materials with practical and not only theoretical recyclability. How to facilitate the recycling of those materials that might be hard to be managed by the users.
This lesson will touch on the topics of understanding the differences and opportunities of end-of-life or waste materials, byproducts and end-of-waste. What technical plus biological nutrients are and how these streams can be useful to organize design, production and end-of-life of a product. The differences between practical and theoretical recyclability. And finally, materials that are difficult to recycle and ideas for improving their reuse or recycling through circular design principles.
Understand the differences between end-of-life or waste, byproduct materials, and the concept of the end of waste. End-of-life or waste materials are discarded from industrial operations, derived from manufacturing processes, or thrown away by consumers. They may or may not be considered hazardous and their management and treatment are regulated by law. If no recycling streams exist, energy recovery may be an alternative to landfilling. From a circular economy perspective, end-of-life or waste should be avoided. Byproducts are excess materials that are materially like the primary product and can be used directly in the primary process or other integrated productions where reuse is also certain. Often manufacturing scraps and regrind are byproducts that can be recycled back into production. End of waste is a regulated condition when a certain specified waste ceases to be waste. In the EU, this currently is applied to certain metals and glass materials. End of waste facilitates the recovery or recycling of waste for use as a resource, to directly replace the use of raw materials.
How to privilege easily separable technical and biological nutrients. Technical nutrients are made of highly stable materials, metals, minerals, plastics, which can be used again within a closed-loop cycle of sustainable manufacturing. Biological nutrients are materials that come from nature and can be safely returned to the biosphere via composting or similar biological processes. Understand where technical and biological material flows occur in your manufacturing process. Technical and biological material flows don't mix and should be handled separately. According to the type of product manufactured and its life cycle, identify the material flow most appropriate for your product and production process. The knowledge of technical and biological nutrients and their different material flows is also relevant when designing for disassembly. For example, without using glue, wooden elements, biological, and metal screws, technical, can be separated.
How to privilege materials with practical and not only theoretical recycling. Reusability, recyclability and recoverability of products are determined by their material composition. It is the case of theoretical recyclability when materials are technically recyclable, but are not accepted by existing public single-stream recycling programs. Instead, with practical recyclability, the materials are recyclable and suitable for municipal, local, corporate recycling programs or end-of-life solutions. The following criteria must be taken into account. Recognizability, what type of material is it? Sortability, can it be sorted into an existing recycling stream? Available collection systems, such as local curbside programs. Also, environmental product declaration, EPD, and material passports can help identify the material composition, a suitable recycling stream in the overall carbon footprint.
How to facilitate the recycling of those materials which are hard to be managed by the user. Investigate if your product can be recycled or is made of recyclable materials. Aim at replacing unrecyclable materials with recyclable ones. Understand recycling regulations in relation to your product. In general, each article and product is identified by a waste and recycling code. If your product has a waste and recycling code, evaluate a proper recycling stream. If not yet, is it possible to identify and assign a waste and recycling code, or can it be replaced by a product that already has such a code in order to facilitate recycling? Design for disassembly to reuse or recycle the different components separately. Also consider the overall carbon footprint of your product. Is it a durable product with a long lifetime? How much energy is required for its production, and the production of materials it's made of?
Conclusion: current times are conditioned on the one side by the scarceness of raw materials, difficult procurement, and reorganization of supply chains. And on the other hand, an incredible amount of waste, materials, and products are consumed and discarded rapidly and thrown away approach instead of preserving and repairing. Understanding, integrating, and using the knowledge of life cycles and circular design principles to your advantage can help to define a different, more sustainable way of manufacturing.